Alright, so I made this simple application that will help you in logging certain data from Arduino, ESPs, STM32s, and others. As I mainly work in embedded systems, I need to log data often. And so this current state of the project is it is able to log multiple devices concurrently using multiple threads. So basically the idea is each logger will have its own thread. So disconnecting one of them will not affect each other. So I mainly use this if I want to log multiple devices while being freely able to adjust the device without disturbing the other device that's still logging. And for safety reasons, there is still a bug, mainly in the baud rate. So if you somehow incorrectly set the baud rate, for example the Arduinos are communicating at 6900 and you set it 4800, then it won't work. The app will crash. That's the main bug right now. But other than that, the app is functional. So let me demonstrate it a little. So oh yeah, I also included installation. So you just need to clone this and then make sure you have Python 3 pipenv and Python 3 pip, since I use pipenv to manage the dependencies. The dependencies are only two, which is PyQt5 and PySerial. You then go to your clone directory and then install the dependencies using pipenv. After that, you have to activate the virtual environment using pipenv2. You can do this using pipenv shell and then run the main.py file. Alright, so now we are in the project directory, and for your information, I also included a simple template code for the Arduino, which is just basically for sending a simple message. And as you can see, the message is up here, and I declared it as a constant string. So it just sends this string over and over every 2 seconds. Alright, and now for the baud rate, I set it to be 9600, and we have to make sure this baud rate matches with what we have in the application. Okay, no time to waste, let's try the application. And let's not forget to activate the virtual environment, and after that we can run the main.py file. As you can see, now currently I don't have any device connected, so it's empty here. I'm going to connect two of my devices. One of them is an Arduino Uno and the other is a Node MCU, I think V2, which is just basically an ESP dev board. Right, wait a second. Right, I have connected it. But why is it still empty? We have to press the refresh port, and there you have it. Now say I want to log my Arduino first, which is just basically ACM blah blah blah. Now after that, let's not forget to set the baud rate to be the exact same, in this case 9600. And I also included several common baud rates that you can use. Now I'm going to give this logger a unique name, and you can name it however you want, but for simplicity I'm just gonna name it uno.txt. I'm sorry, uno. Let's say uno1, because why not? And for the log file. You can name this however you want to, but for simplicity, let's just name this the same as the device with the txt extension. Alright, pressing add will start the device, meaning the device will start to log data to the log files specified here, and you will see some information message printing at the standard output of my terminal here. Right, let's start. As you can see, it found the device and the device replied. If the device replied, meaning the device has started logging. If you somehow don't see this message printing, then you may have set the baud rate the wrong one. Alright, so wait a second, let me just make this always on top. So if you somehow didn't see this one, then you must double check your baud rate. Maybe well, we are humans, we make mistake. Alright, so now I want to log my ESP2 together with my Arduino at the same time. This will create a new threads different than the threads that the Arduino is using. Alright, so let's name this node MCU, and for simplicity let's just name this the same. Alright, let's start. And it replies successfully, which means the device has started logging. And if we want to take a look at the contents of the file, we can do so by looking at the log files. In this case, let's take a look at uno1.txt. As you can see, it prints a simple message. And for the sake of convenience, I also put device number at the beginning of the string. This is done from the application side, not from the Arduino side. So it's just, if I want to log multiple devices, I can just say this is device number 1, this is device number 0, and that's just for me. You can ignore this if you want. All the important messages are after this comma, which is hello from the Arduino Uno. Now let's take a look at the contents of the node MCU log. As you can see, it prints a different device number, and also the log file contents is here. Hello from node MCU v2. Yeah, it's v2. Right, so now if we want to close the app, we have to disconnect all the devices that are currently connected. If we somehow close the app before all the devices are disconnected, the thread will not end, and your program will just hang in here without knowing how to end the thread. And that's just how I set it up to be. Now I'm going to disconnect the devices, which is in my case just a USB hub, so I can disconnect the USB hub to disconnect all my devices. As you can see, it disconnects all of them, and it's printing a simple information message. Alright, and also the table is updated. Now if we want to close the app, it is safe to do now. Bam, as you can see, it ends without a problem. Alright, I want to thank everyone for sticking with me until the end of this video demonstration. And I consider this project imperfect because it's my first serious project. And for your information, I'm not a software engineering student. I'm an electrical engineering student. Currently, I'm in my 4th year. I'm now in my holiday and I just want to create something, so it becomes this project. And as I'm an electrical engineer, as you can see, my code is not quite good. I'm not quite knowledgeable about software engineering stuff like the design pattern and such. And if you take a look at my code, it is actually not what you expected to be, and I'm sorry if I didn't meet your expectation. And I know you can design the GUI using PyQt GUI, and I just knew that. So there is still a lot of imperfections in me, and I know my English is strange. Alright, and as such, I still want to thank you everyone for sticking with me until the end. If you are interested in this project, you can clone this, use it however you like. And if you want, you can also try to contribute this project and we can talk about it. I'm open. And I just got a confirmation from my friend, which is using Windows and Mac OS, that this program works on their side. So Windows, Mac, Linux, and Raspberry Pi works because I designed this program in my Raspberry Pi. In fact, I coded in my Raspberry Pi, but currently I'm in my laptop, so it works for all the platforms. Alright, and so I want to thank everyone for again sticking with me until the end of the video. Thank you everyone, see you in the next video.